Hello wonderful person, this is Anton, and in today's video we're going to be asking and answering a simple question. So how many planets can you actually fit inside the habitable zone of a star? In other words, on average, how many planets can orbit successfully in the region where you have liquid water? Let's find out and discover the answer. Welcome to What the Math. In this particular simulation, we're looking at Kepler-62, and you can kind of see that the habitable zone for this star system is right here. Now, this is actually a real solar system we've discovered in the last few years, and it actually has 5 planets we've discovered, known as Kepler-62b, C, D, E, and F. Now here's the thing about various solar systems that we've discovered. We found approximately 3,500 various exoplanets so far, and we've discovered that various stars seem to have these planets either really close to the star or really far from the star, and sometimes, just sometimes, in the habitable zone. There's actually quite a few of these real solar systems available to us in the simulation, and I guess the most famous one is Proxima b, which is the closest star to us and the closest terrestrial or Earth-like planet. This is something we've discovered in 2016, and it kind of looks like this in Universe Sandbox. So there's Proxima b. It sort of has an Earth-like parameters. It's very, very close to Proxima Centauri, which is a red dwarf, and it orbits around its parent star and kind of possibly looks very Earth-like, or maybe not. I guess maybe one day we'll discover. But according to Canadian astronomers, specifically from University of Toronto, one day someone actually asked, so, okay, well that's one planet, but how many can you actually place in this region and still have a stable solar system? In other words, how many rocky planets can I actually place in orbit around Proxima Centauri and still sort of have a system that works? Now, it's a very interesting question. It's a question that nobody ever asked before, but it's a very interesting question because it allows us to do mathematical analysis of a stability of a solar system and also find out if somewhere out there, there's possibly a solar system that has not just one, but several Earth-like planets in the habitable zone. So, how did they actually answer this question? And the answer came from a person by the name of Christa van Leeuwenhoven, who works for the Canadian Institute for Theoretical Astrophysics in Toronto, and she basically examined various simulations and tried to do a little bit of mathematics and used various simulations, placing various amounts of planets around the most typical stars in our galaxy, and then seeing which ones were stable and which ones were not. Now, she used only red dwarfs, specifically stars like Proxima Centauri, because these are basically like 90% of all of the stars in our galaxy. Most stars are actually similar to Proxima Centauri and not our sun. Our sun just happens to be a little bit more giant, a little bit more hot, and a little bit more interesting, but also more stable than other stars. But Proxima Centauri-like stars are very, very common. So they, even in here under the stars, you'll find quite a lot of them. Like, for example, Evi Lacerta is yet another star. Barnard star is also very close to us and also very looks very similar to Proxima Centauri. So a lot of these red main sequence dwarf are actually quite common. And that means that we really should be looking at these particular types of stars as a possible potential home for us in the future. Because if they're very common and if they seem to have planets in the habitable zone, and it seems to be quite a common phenomenon for stars to have at least 1 or 2 planets orbiting around them, it's very likely that we might be able to discover a habitable red main sequence dwarf somewhere out there with an Earth-like planet. And so let's actually run the simulation. We're going to run this a little bit faster and see if any of the planets survive. But you can kind of see already some of them are being kicked out of the habitable zone, and some of them might actually end up leaving the solar system. But essentially, so these K and M types of stars are not only very, very common, but they're also very, very stable, and they live for a very long time. They live so much longer than our sun. Because they're smaller, because they have less mass, they can produce energy a lot longer. As a matter of fact, Proxima Centauri might survive for close to 1 trillion or even several trillion years, which is several hundred times longer than our sun, which will only live for about 5 more billion years. So in other words, if we're looking for a new home, we really should be looking for these very dim red main sequence dwarfs and not more bright, more active stars, because they are definitely a lot less stable. And this, of course, also means that these types of stars will have a lot more time and a lot more possibility for not only life to develop on them, but for very interesting, stable planets with stable atmosphere, stable everything, including potentially a magnetosphere, which is very important for us, to develop over time. Now you can see that interaction with these various planets here has already caused one of the planets to go in a completely different sort of plane of orbit and become a fragment, because I think there was actually a collision there somewhere. But we're just going to see how many of these planets will remain in this particular tight orbit. And so Christa von Leierhofen decided to basically run the simulation for essentially what would count as several billion cycles, so essentially several billion years of a local system, possibly a little bit less in terms of time on in our solar system, but let's just say this was about billion years. She ran this for about a billion years and discovered that for the most part, the number was very similar. The number of planets that remain in this habitable zone was always 5. Now, let's see how many we have. We're going to go through our system and find out how many stable orbits remained, and we're going to actually remove all of the fragments and all of the particles if they are here. And let's see how many of these are still around. So we're going to erase the ones that are not in the habitable zone anymore, even though I originally placed them there. And now we're actually down to about 7, but you can see the orbits are still kind of changing. So I think this one here is about to escape as well. So we're going to erase it on top of all the other stars. So we're down to 6 now. And let's run this a little bit more, maybe a little bit faster. But you can see they're slowly stabilizing. They're slowly becoming more and more stable, even though they're still changing and interacting with one another. And it's very likely that I'm going to get a very similar number to what they actually got as well. And the magical number is actually 5. So let's see if we get to 5. And a few years later, so we're at 5 now, but they're still sort of interacting with one another and changing each other's orbits, but they're definitely a lot more circular and a lot more stable looking than before. You can kind of see they're sort of stabilizing each other and causing one another to orbit in different locations of that habitable zone, which is green here. But this is what they discovered. So a typical red main sequence dwarf would have approximately 5 stable planets orbiting in this region. In other words, what this suggests is that somewhere out there, there's definitely at least one of these red main sequence dwarfs that has exactly 5 habitable planets. And this is simple statistics. It's very likely that there's one somewhere. We obviously might never find it, but it exists. It's definitely out there because mathematical models state that you can have up to 5 stable planets in this region. So it might actually look something like this. And so here is a somewhat typically stable system that they've discovered. So there's a red main sequence dwarf in the middle and 5 rocky planets that are far enough from each other to not gravitationally influence or affect each other's orbits. So I can possibly run this for many cycles and it will still kind of be relatively similar. They might wobble a little bit until they reach some kind of a stability, but they won't really affect each other too much. And this is essentially the discovery. So there's definitely at least one star out there mathematically, and it'd be fun if we actually discover it one day and possibly even decide to colonize it, because this implies that you can have each of these 5 different planets as terrestrial planets, and you can actually have a colony or have an actual city on one, and then even see the other ones if you look into the sky. And if you were to look at the closest planet to you, it would be about 6.7 times smaller than the moon in our sky, but you would be actually able to see other cities as well. So let's actually see if we can maybe go ahead and terraform these planets. We're going to give each one of them enough temperature and enough atmosphere and also enough water to actually have terrestrial look to it. And then go on a bit of a tour of this imaginary system somewhere out there that might actually have these 5 terrestrial planets. So here's Proxima b. Obviously, this would not be Proxima b because we haven't really discovered any other planets around Proxima b, but they might still be there if they're a little bit smaller. And these are all procedurally generated, but absolutely beautiful. And each one of them has a terrestrial look with liquid water, atmosphere, and necessary temperature and pressure to support human life. Except for this one. I don't know what happened to this one. And so here's the planet number 4 and planet number 5. So these 5 worlds are essentially a very theoretical sort of idea that might definitely exist somewhere out there in our galaxy, or definitely somewhere in our universe, because the amount of these stars present and the chance of this happening is actually relatively high. But the only problem with this particular model is that normally these smaller stars might not actually have enough material to form so many planets. And this is something that we're still investigating, and we're still trying to discover if it's possible to have 5 planets in a red main sequence dwarf system, because this type of a star would obviously have a lot less mass altogether. But it's still possible that maybe there's enough mass to create 5 terrestrial planets, just not gas giants, because if I were to place a gas giant here, like Jupiter, it would definitely be massive enough and large enough to completely disrupt the system and cause everything to lose its orbit. And you can see that happening already, because Jupiter is very, very massive, contains something like over 300 Earth's masses in it, and it does have a lot of gravitational influence on various objects in our own solar system. But all in all, that's really all I wanted to answer in this particular video, and I wanted to show you how many planets can you actually have in the habitable zone of a typical, most common type of a star in our galaxy, and the answer to that is about 5. But if you place a gas giant in there, it basically sort of destroys the system completely, leaving nothing behind. So you can see Jupiter essentially got rid of all of the other planets except for one. There's still one left in the center, but it's probably not going to survive there for a very long time. And so anyway, so that's all I wanted to do in this video. Thank you so much for watching, and hopefully you learned something from it, and hopefully you subscribe if you still haven't. Don't forget to share this video with someone who enjoys learning through video games, and come back tomorrow for another video that is going to be educational and awesome, and we might even just play a video game and you might learn something from it. I'll see you guys in the next video, game you later, and as always, bye bye. And it's only taken Jupiter a few years to basically completely disrupt the system. You can see it has so much gravitational influence here that everything is basically being kicked out. There's that planet that just got kicked out of the solar system, and only one of them remains in the center. So maybe this is actually what may have happened to a lot of these solar systems if they develop a gas giant. If there's a gas giant somewhere out there, it's obviously going to disrupt a lot of other planets and kick them out, or have them orbit a lot farther away from the center of the star, making them inhabitable. Anyway, see you guys later, see you tomorrow, game you later, bye bye.